Okay, let's start with today's training. Hello everyone, welcome to today's training. Today we will continue to introduce our PLC I/O module, and now we can start it with the LX3V16EX module. This module is supports for 16X input. So if you use a small PLC and if you want a more input in terminal, so you can use this module in your project. And here we can see this module supports 16 input terminals. Is from X0 to X7 and X10 to X17. And the SS terminal is the common terminal. And here is a link LED here. It shows the it shows the state between the PLC and the extension module. And when you work normally, the LED flash is flash. So if it keeps lighting, it means the software is abnormal or the hardware is faulty. And the link is off. The data transmission is abnormal, stopped or failed. This is the picture about the modules wiring. So you can see in this picture, it just shows the NPN connection. So, and this module also supports a PNP connection here. So SS terminal can connect to the power supply, positive pole or negative pole. This I/O input points on the module are named from the next X point. Use the points on the host as endpoints. For example, if you using a PLC is LX3V1212MRA, and in this PLC host, it has 12 input points. Yes. And the point then is from X0 to X7 and X10 to X13. So if you connect a module LX3V16EX, so the X point defined in the module on the host are X20 to X26 and the X30 to X37. Yeah, so if the input signal is from X0 here, so it means in the program you can use X12 to X20 directly. You will be more clear with this picture. So this is a LX3V 3624MT, and we connect two LX3V 16EX module here. So this is the first module. With the PLC host, the input points is from X0 to X7, X10 to X17, and x20 to x27, x30 to x37, and x40 to x43. So the module here, the name is from x60, x50 to x57, and x60 to x67. And the third module, the last one, is called from x70 to x77 and x100 to x107. So if we connect another module here, it will also from x110 and to 116. Okay, so we also have the output module here, named LX3V16EY. It has two types, LX3V70EYT. It means the transistor type module, and if you use the LX3V16ER, it means it's a relay type module. It also have the link LED to show the state between the PLC and the expansion module. And the same inductor light state. And for this output module, they only support a PN connection. So, and in this group, and in this picture, you can see the module divided into two groups. The first group is from is COM1 with Y0 to Y7, and the group 2 is COM2 with Y10 to Y17 here. And the terminal we need to use from this module is also the same. By the way, all the digital input and output module have the numbers of limits. In principle, the number of all input points X must not exceed 56 points. So it's also the same for the output module. The number of all output points Y must not exceed 256 points. And also with this picture, now we connect two LX3V16EYR and this module here. And now the output of this PLC host is from Y0 to Y7, Y10 to 17, Y12, Y20 to Y27. So the first module here called by here is Y30 to Y37, and Y here is wrong. Here is Y40 to Y47, and the third module here we it called by the host are Y50 to Y57 and Y60 to Y67. So do you have any questions about this two input and output digital module? It doesn't have any relevant special register or some special programming, you can just use the, so here, for example, here Y60 here for Y0 here. Okay, let's move on to the BG module. We have a lot of BG module here, but I just mentioned some typical one. The first is LX3V4ADI BD. This BD module is a digital analog convention module, and it's for the here is current input is for 4 to 20 milliampere, and the data of all the channel after convention and stored inside the special register. And here we can see it also has, you can see here it has 4 channels on this BD board for the current input. And in this BD board also have the LED light to show the different state of each channel and the communication state and the power state. So if it works normally, it will consist on, and it blinks when the analog signal is out of the range. This is a special register for the BD board in LX3V. As I just mentioned in yesterday. And if we need to use this BD module in LX5V, so it have different related addresses here. You can refer to yesterday's class. Okay, let's move on. And for this BD module, we can't change the input characteristics. So if the module received 4 milliampere analog input, the value is zero. So if the BD module received 20 milliampere analog input, so the value will be 2000. This is a basic program. So before we start use this BD module, we need to reset the special register M8112 for channel 1 to set the channel 1 as the current input, and also the same for the channel 2 to reset M8113. And then we can get the digital value from D8112 for the value of channel 1, and the value of channel 2 will showed in D8113, and we can use MOV instruction to get the value to D2. Because the LX3V 4DAI PD module doesn't have the offset and gain function, so if we need another digital range here, so it needs we made some program to a conversion here. For example, if we need the digital range is from 4,000 to 20,000, so we can use MUL and ADD this arithmetic instruction here to adjust the value we get. Here we didn't mention it in PPT, but it mentioned here. The resolution is here. You can get more information from our support center. Yes, this is just an example. You can also use D1 here. Okay, let's move on to another BD module. It's LX3V 2DAV BD module. Its output the voltage based on the digital value the BD module gets. So as you can see, it also have the LED light to show the state. And with the same relative channel addresses. All the BD module in LX3V is the same if you use the expansion port 1, it's here, and if it was module 2, and it have the same input characteristic here. It's the same as the default character for LX for DA, for DAV. So it's also if the digital input, digital input is 0, so the analog output is 0. So if the digital input is 2000, so the BD module will output a 10-volt voltage. So it's also the same for the basic program. Before we start use this BD module, we need to reset the special register to set the channel 1 into voltage output mode and set the digital value to D0 and change it to the special register D8112. So the BD module will output the corresponding voltage. Also, if we want to change the digital range we input, so we also need to use some arithmetic instruction. Here I see this video module for DAV. Just like this program, to change the digital range to get the same voltage output. I think it's very simple. It's just to change. We just want to set a certain value and use div instruction here to get a new value and set this new value according to the default input characteristic here and send this value to D8112. Yes, both these two modules can be used in LX5V here. And now I will show you the demo here. Here I just use the module here I use is LX3V 2AD and 2DA BD module. I'm sorry. I will show you in the picture. We can see use this. This is the BD module I used now, and this is the program. And here I didn't use the special register as the menu set here, M8112 and 28115. I just use the special register for the LX5V. So here is SM 2012 to 2013. We start with the first part for the analog output, signal output here. And now, if I set the SD, the value of SD 2012 to 500, and you can see in the meter is I didn't show it totally. Is now the output voltage is 2.48 volt. So when I change the value to 1000, so the output voltage is 4.98. It's basic this input characteristics here. Okay, let's show it again. So here I just set the value for here is 1000. And you can see here the first channel. The first channel is the analog input channel, so it also gets the value. Because the BD module is a little old, so it has some error here. It's not exactly the same, the value. And if I change it to 1000 and to 500, so it also changed. Okay, so let's move on to the last type module. Is LCM module. We mentioned this type module yesterday, so let's see is how we use this LCM 16 in the EX module here. This module is communicate with PLC by the Modbus protocol. So the first we need to we can see it also have the link LED, show the communication states, and from this picture of wiring, we can see this module also support PNP and NPN. Okay, let's see how we can use this module with the PLC program. Because this module communicates with PLC by the Modbus protocol, first we need to set the module's communication parameters. As we mentioned yesterday, we set the parameter by the DPI switch. So the DPI switch 6 to 8 is for baud rate. And the first 5 DPI switch is for the station number. So here I set the boundary rate, the communication parameter is here is 15,200 and 1/8 even here. And we can see the station number we set here is 2. So we use this instruction here is used to set the parameter COM2 port as the Modbus master, and set stop bit as 1, data bit as 8, even priority, and the boundary rate is 150,200. And the second part here we set the RS instructions parameter here. We set D1 we set is the read instruction function code here, and D3 is the data length we want to read from the module. So with this RS instruction here, we can get the data from the module and save it to the D10 register. And by MOV D10 K4 M10 this instruction, we can map it to X0 to X to X16 here is to M10 to M25. So if X0 is on here, get a signal, the M10 will be on. Also, if the X17 gets the value, the state is on, so the M25 also will be on. And then we also have the output LCM module. It's also the same. T means the transistor type, and R means the relay type. This picture also shows this module needs the DC 24-volt power supply and the serial port. The light shows each terminal's state here. The link LED shows the communication states. So when you work normally, the LED blinks. This module supports the output terminal support AC supply, power supply, or DC power supply. If you use if you use relay type module, but if you use the transistor type module, it only support DC power supply here for the output terminal, and the module only supports NPN connection. Here is the program for LX3V to work with the LCM 16EY module. It's also the same. The first, we need to set the parameters for communication, and the parameter for the RS instruction here, we can write the state from M10 to M25 and to the Y0 of the module to Y7 and Y10 to Y17. It will map to the M10 to M25 here, and we can also get the state from this module. This is the LX3V program, so I will show you how to use the LX5V to connect this module. At first, we should set the communication parameters. So here I already set the module's boundary rate as 9,600, and the slope bit is what priority is even, and set the PLC as the model bus master. So for the LX5V, it doesn't need these part parameters. We set these part parameters by the configuration interface. And then we also set the IS instruction parameters. D1 is the write to write, and D2 is to read the module state, output state, and the D3 is the length. So here I mapped M10 to M25 to Y1 and Y1 to Y7, Y10 to Y17. So let's download the program. Okay, so now I check M10 here. And if you have this module, you will see the, I will take a picture here. As you can see in this picture, the LED 10 is on now. So if so you can see M10 here is the state of Y10 here. And if now I triggered M19, and take another picture. now the Y1 is on here. So you have a different part different corresponding here. So M10 is not the Y0, it's Y10. And with this IS instruction, we can also get the state of the output now. So here we get the output and save the value to D20 and move D20 to K4M50. So as you can see here, this state is corresponding to M15. 50 is corresponding to M10. So if I triggered M14, and you can see M54 is also on now. So with this demo, we showed how to write the output to the module and how to read the output state from the module. Any questions about this LCM module? Because for the digital output module and the digital input module is only these two modules now. Okay, so if you have any questions about the module and the BD board I introduced today, you can leave your questions in our group, and I will share these two demo after the training finished. I will also share it into the group. Okay, and one more thing I want to mention is about yesterday's after class exercise. It's okay if you don't have the module with the exercise mentioned. You can just use to make a program. This exercise just to let you practice how to set the offset and gain value. So I think it's no. So if you don't have this module, it's okay to send your exercise. The value we need to set is just based on the HMI project I shared yesterday. Just to set the range we need, and we will get the gain value and offset value we want, and use this value in the PLC project. It's about, I will refer to some files and answer your questions after the training, because I think it depends on the boundary rate you set. I remember different boundary rates will have the different length of the communication cable. Okay, any other questions? Okay, and I will leave today's training, today's after class exercise later. So just remember to submit your after class exercise. It will related to the final exam. If I once use PID temperature, okay, must I? It's not necessary. You can also use the LX3V4TC. But if you use this, but this LX3V4TC just to get the temperature value. So if you want to use the PID control, you need to use the PID instructions in the project individually. So for this LX3V4LTC module, it has a built-in PID function, so it's more easy if you want to use PID function. It's also okay if you use LX3V4TC module, BD module. Okay, if you want to, if you have any other questions, you can leave your message in our group. So today's training will be finished. The next training will start the day after tomorrow. So please attend the training in time. Thanks for everyone. See you.